Greetings. Today we are looking at measurements. As you are getting ready for the exams, you need to understand these three measurements. This is physics. This is science paper 1. So question 1, it is always on measurements. We can either give you the Vernier calipers, the measuring ruler, the micrometer, screw gauge, or even a pendulum. Right, so we will discuss these three measurements, and then we'll look at practical examples from the past papers. Right, to start with, we have a Vernier calipers. What is this Vernier calipers? So the Vernier calipers just measures an instrument that measures the length of an object. It measures the internal and external diameter. So that is the structure of the Vernier caliper. It has got the main scale, the Vernier scale, and also the jaws where the object must be placed on. The inside jaw and the outside jaw. So the object has to be put there tightly. How do we use this instrument called the Vernier calipers? So the first thing that we need to do is we need to put an object which is supposed to be measured on these jaws. We need to put the object on these jaws. After that, we need to read the main scale reading. Where is the main scale? This is the main scale reading. We need to read the main scale reading. How do you read it? You read the mark, the zero mark of the Vernier scale. The zero mark, this is the Vernier scale. So you have the main scale and you have the Vernier scale. So you read the zero mark of the Vernier scale. Then you need to look at the Vernier scale and find a marking on the Vernier scale, that is the line with the main scale. Okay, we're going to do a practical. We're going to see how it's brought in an exam. After you get the measurement from the main scale and the Vernier scale, then you need to add them. You need to add the readings, the main scale reading plus the Vernier scale reading. That is how we're supposed to use this instrument. So let's get a question from the past paper. Okay, so this is the example we have there. So how do we calculate? So like we said, we need to read the zero before the zero mark of the main scale, and then on the Vernier scale, we just check where the lines are meeting. Like here, in all the diagrams, there will be a line where they will be meeting. Right. So how do we read the main scale? So this is our 0. So if this is 1 and this is 2, so this is supposed to be, so this is 1, 1.1, 1.2, 1.3, 1.4, 1.5, 1.6, 1.7, 1.8, 1.9, 2. Okay, so before the 0, so we have 1, 1.1, 1.2, 1.3. So from the main scale, we have 1.3, our readings. The Vernier scale, we follow where the lines are meeting. So on the Vernier scale, you follow where the lines are meeting. So now if this is 0 and this is 5, that's where they are meeting. So this 5, that is where they are meeting. At least this one is clear. So the 5, you're going to multiply it by 0.01. You're going to say 5 multiplied by 0.01, giving us 0.05 centimeters. So we're going to say the main scale plus the Vernier scale. So the main scale we said is 1.3 plus the Vernier scale, which we have said is 0.05. Then when you add all this, you are getting 1.35 centimeters. So this is how you take the readings on the Vernier calipers. So try these two on your free time as we move on to the micrometer screw gauge. So when you look at the micrometer screw gauge, the micrometer screw gauge, it just measures the diameter of hair cc imishishi, or thickness of a razor blade. Even the thickness of a wire, can be measured by the micrometer screw gauge. So this is how the micrometer screw gauge looks like. So it has got the anvil, the spindle, the sleeve, we have got the thimble, and we also have the ratchet this side. So we have also two points that we need to get here. We have what we call as the main scale, and there's what we call as the circular scale reading. Okay, so how do we use the micrometer screw gauge? Right, so the first thing we need to do is to turn the thimble until the object is gripped. So the thimble this side has to be turned until the object is gripped. So this object here must be gripped very tight and gently. After that, you need to read the main scale on the sleeve before the edge thimble. So you need to, this is our main scale. So this is our main scale. And it's been a while the last time they brought this, and then they say label the parts. So you need to know the parts. So we have this main scale and we have the circular scale. All right. So you need to look at the circular scale and find the line that is horizontal with the main scale here on these divisions. So the line that is horizontal to the main scale. So we have 10 here, we have 14 here. So same as we have 10, 11, 12, 13, 14. So the line which is horizontal to the main scale is here. So this is our reading on the circular scale. So now, if at all the circular scale here, it is like here 10, 11, 12. So if this is 12, so we need to say 12 multiplied by 0.01 millimeter. That's how we're going to get the readings on the circular scale. So now, when you on the main scale, you need just to get the last point. Okay, so we'll do the one which will have numbers. From there, you need to add the main scale plus the circular scale. Okay, so let's try a different example. So here is our question. As we can see there. Okay, so like we are just from talking on the how we can use this instrument. So we said we get the readings on the main scale and we get the readings on the circular scale. Then we just add them. So if we can see here the main scale, here we have the circular scale. So on the circular scale, we said the point that is horizontal with the main scale. So this is our point there. Then you need to multiply it by 0.01. So if this is 10, we have 11, 12, 13, 14, 15. So this 10, 11, 12. So this is 13. So we're going to say 13 multiplied by 0.01, giving us 0.13. So this is the circular scale reading. So this is the circular scale reading. Then we get the main scale. The main scale will just get the last point. So if this is 1, 2, 3, 4. Okay. So remember we have two points here. So if this is 1, this is 1.5. This is 2, 2.5, 3, 3.5, 4, 4.5. So our last point here is 4.5. So we are going to say 4.5, you add 0.1, supposed to be 1.3, because the divisions were 13, 10, 11, 12, 13. Here it was 13. 13 multiplied by 0.01, giving us 0.13. And then from there, what have we said? We have said we are supposed to add, what are we adding? We are adding the main scale plus the circular scale. So our main scale is 4.5. Then you are going to add 0.13 so that you can get you're 4.5. You're adding 0.13. Then you're getting 4.63. So there was an error here. So this is our answer there. Right. So the other thing you need to take note is the accuracy of both the micrometer gauge and the vernier calipers. Once you understand this, you can go answer these two questions that I've given you. So we have this one. So we have 1, 2, 3, and then so you just pick the point where the horizontal with the main scale, this point here, and then you get the last uh, point here also on the main scale. Same applies to this one. So try this one on your own as we go to the vernier, sorry, the pendulum now. So when you look at the pendulum, how do we describe a pendulum? So a pendulum is just a small heavy bulb which will be suspended by a string. This is a bulb suspended by a string. So this is a string that we have there. Right. So how do we use this pendulum? So you need to clearly understand this. So from point, so the bulb will be let go, then it will swing from A to B to C, back to B and back to A. So this is one complete oscillation or one complete swing. So that is how a pendulum moves. So it will move from point A to B, C, back to B, and also back to A. So this is now a full or a complete oscillation, one complete oscillation. So now we need to understand that for the bulb to move, so to move from A, B, C, B, A. So if the bulb moves, if the question says the bulb moved from A to B, so from A to B, the number that you are going to get from here, so from A to B is 1 over 4. When you divide 1 over 4, you are getting 0.25 is the number of oscillation. If the bulb moved from A to B to C, it has moved 1, 2. So it's going to be 2 over 4. And when you divide 2 and 4, you're getting 0.5 as the number of oscillation. So from there, the bulb comes back now to B. So to B, so it has moved 1, 2, 3. So it's going to be 3 over 4. And lastly, if it goes now back to A, that is 4 over 4, which is now one complete oscillation. So you need to also understand that there is a part that they call the period. So what is the period? The period is just the time taken for one complete oscillation. And the period is given by this formula, which is capital letter T. Say capital letter T, which is period, is equals to time divide the number of oscillation. Right. So now, as you let go of the bulb, you hold the bulb, then you let it go, then it starts to swing. So immediately you let the bulb to start swinging, you even set the time on your stopwatch. That's why even on the formula here, we have period is equals to time divide the number of swings or number of oscillation. Then there's also what we call frequency. And frequency, the units are hertz. So the units for frequency, they are hertz. So we use this formula when we're getting frequency. So frequency is equals to 1 divide, remember, capital letter T stands for periods. Right. So let's do a practical example. Figure below shows a simple pendulum. So this simple pendulum is oscillating between position A and C. All right. So as we can see there, this is our simple pendulum that's got a support. And mind you, this length also affects the swings. The length here affects the swing. If they ask you, state the factors that may affect the period of a pendulum. So the length here affects the pendulum. All right. So this is our bulb. Our bulb is moving. How is it moving? So it's moving from A to B to C and back to B. Okay, so what are they saying? They're saying if it takes 2 seconds, so here it takes only 2 seconds for the bulb to move from A to C and back to B. Okay, so then kawera pa B. So find the number of oscillations. We are just finding the number of swings here, and this is very, very straightforward. Find the number of swings. Remember, here we say this is 1/4. Here, this is 2/4. Going back, this is 3/4. So they want us this to find this. Sometimes the questions they ask, you may even wonder in an exam. So let's see. Be ready for these questions. Right. So they want us to find this as it moves from A to B to C back to B. So what is this? So we are going to say this is the 0.75 oscillations. That is our answer. Or if you want, you can say 3/4. If you want, you can say 3/4. Because when you divide 3 and 4, you are getting 0.75. So that is our answer. Okay, let's go to B. So this is our A. Let's go to B. B, they're saying what? Calculate the period of the pendulum. Calculate the period of the pendulum. So if we follow clearly this question, they have given us time. They have given us time. Okay, they have given us time, and then we have also find the number of oscillation. So what are we going to do? We are going to say period is equals to time divided the number of swings or number of oscillations. So time, they have given us 2, these 2. Going to divide number is this one that we have found, which is 0.75. So what is our period? So when you divide there, you are getting 2.67 seconds. So that is our period. What have we done there? We have just divided 2 and 0.75, which is giving us 2.66666. So now we have just rounded up to 2.67 seconds. Period is measured in seconds. Since this is the time it takes, so period is the time it takes. That's why time is in seconds. Let's go to C. C, I'm going to answer it where there is space. Calculate the frequency of the pendulum. So you can't calculate the frequency minus finding the period, because the formula frequency is equals to 1/period. So without the period, you can't find the frequency. So first you find the period here, which you found here to be 2.67 seconds. Then we're going to use the same period. So the way physics is, questions they relate. You will discover that question B will require an answer from question A. Again, question C will require an answer from question B. All right, so frequency is equals to 1 divided period. So 1 divided, what is our period? Our period there is 2.67 seconds. So now, when you divide there, you are getting frequency is equals to 0.37. Frequency is equals to 0.37. And when you leave it like that, the answer is wrong. It has to be in hertz, because the unit for frequency, it is hertz. Never should you forget. So we have just divided 1 divided by the period, which is 2.67 seconds, giving us 0.7 hertz. So this is how you do questions on measurements. So make sure you practice more questions, because there has never been a paper without questions on measurements. Go through micrometer screw gauge, go through Vernier calipers, and go through pendulum, and thank me later.